So thank you very much. Next, I would like to introduce Dane. So Dane Ralston is the CEO and founder of iOpt Limited. Founded it back in April 2016. For the last 20 years, he's been working in asset management, helping make more with assets like Aston Martins and engines and that kind of thing. Now looking at social housing, the owners, the managers, the tenants of these properties. So Dane, over to you to talk about helping tackle the cost of living crisis using the Internet of Things, a census case study.
Sorry. Thank you, Sarah. Thank you. Wondering if this is a clicker to click things back. It is? Okay, good stuff, good stuff. Good afternoon, everybody. Nice to be here. And first things first is really thank you, Census, for putting this on. We've been working with Census for 5 or 6 years now, something like that. And basically, they've been bringing us together with other people from the very start to build this ecosystem. And so it's pretty appropriate that they're one of the first people to get us all back out together after lockdown, which we won't talk about again. So yeah, I'm here to talk about IoT in social housing and how we are using IoT to help councils and housing associations tackle all sorts of issues, but right now, getting more and more to be talking about the cost of living crisis and the energy crisis. Why is it a problem in social housing? Well, quite simply, scale is our customers' problem. Some of our customers own 40, 50, 60,000 properties, and they're spread all over the country, literally from Cornwall all the way up to the northeast of Scotland. So sheer scale is one of the issues they've got. They also are mandated to provide safe, healthy homes, and quite often, that is something that they can't do because they don't get access to homes to know whether those homes are safe and healthy or not. So what we do is give them better visibility of what's going on inside a home with regards energy usage and the environment in that home. And this is no jokes. £1.4 billion a year is spent by the NHS tackling health issues that are brought about because of cold homes. Something like 80% of that is in social housing. What's scary about that is that's data from 4 years ago. So imagine what the numbers are going to be like now that people aren't going to be able to heat their homes and they can't keep up with all of the different costs that they've got going on. So this year, the cost of living crisis and energy will be a killer. It already is, but it will be so much more. We've got customers who are already spending last year, £400 a month on their energy. I just got my prediction in for the next 12 months, and it's £5,000 for the next 12 months, up from £1,300 last year. So imagine how that knocks on to social housing, where your typical income might be about £15,000, and they're already paying more in many cases because they are using prepayment meters. So a lot of people in social housing will be paying more than we are already paying here in this room. So cost of living, why does it have such an impact in social housing, or anybody really? If you can't afford to heat your home, one of the very first things you will do is turn the heating down. The next thing you will do is try and retain as much of that heat in the home as possible. And typically that happens by people closing windows, closing the trickle vents, the little vents you see above windows. And that does retain more heat, but the other thing it does is retain more moisture within the property as well. And that, in turn, has a knock-on effect, not just to the health of the building, but the health of the tenant as well. So respiratory problems, mold growth, all sorts of different things. So you get this vicious circle that just makes things worse. And it's not unusual for us to see customers who have maybe lost their job and they're trying to get another job, but they become ill because they're living at home that isn't healthy, and then they can't go to job interviews or they can't just take on a job. So you get this complete vicious circle. And obviously, one way of trying to tackle that is by making buildings more energy efficient. So not only are we identifying buildings that are already unhealthy, but we're also identifying buildings that are just wasting money. It's not just money, but energy as well that has to be generated somewhere. So from that, again, knock-on effect, vicious circle, what are the outcomes of that? Well, we initially got into this from a retrofit point of view, but I'll get onto that later. What we do mostly now is sort of preventative maintenance, detecting homes that are cold and damp, detecting homes that have been abandoned, that could be being used by somebody who is needing it, detecting homes that are being used as benefits fraud, whatever. So there's the social aspect of it, then there's the financial aspect of that as well. And not just the cost of wasted money on homes that are mold growth, but the fact that that money could be being used elsewhere to help the tenants or the council areas or whatever. A typical landlord with about 10,000 homes spends nearly £1 million a year on tackling mold and damp problems. And that really comes down to people not being able to heat their homes, therefore not being able to ventilate properly, et cetera, et cetera. Quite often, if somebody can't heat their home, then they can't afford to pay for the rent of their home, and that will turn into an abandoned home. Then the problems start to stack up even more. It can take 5 or 6 months for somebody to identify an abandoned home. You might get frozen pipes, all sorts of different issues. So that one landlord with 10,000 homes is spending £1.5 million a year just on rectifying pretty simple stuff. So I think we probably all understand that prevention is better than cure. So how do you prevent all of these kind of things happening in the first place? Well, start with the basics. Monitor the environment within, monitor the energy usage of the home, and try and get in there before you get to not the point of no return, but the point where it's going to cost you 5 times more to rectify. So you're looking at, improving ventilation might cost you a couple of £100. If you leave a home in conditions of 80% humidity, 15 degrees centigrade, pretty typical for what we see, you'll come back to a bill of about £3,000 or £4,000 per room to rectify the damp that's in the plasterboard or whatever it is. So how do we do it? Well, you guys will all understand. Basically, we put sensors into homes. The data from that is collected, sent out into the cloud via whatever radio systems or networks you want to use, whether we use LoRaWAN quite a lot, we use NB-IoT, we use some fiber backhaul into the cloud where we generate reports and alerts that basically are of use and give a heads up to the landlord. The data from that is then generated. Does this work? Nope. Generated and sent out to the platform, which is what most of our customers use. It can go straight to the tenant because that's one of the things you want to do straight off is try and educate the tenants as to why. When we all move into a home, we don't get a pack saying, if you close your windows and you have a shower and you cook and stuff like that, your humidity will rise by 20%. We don't get that kind of education to say why that has an impact. So educating the tenants is very critical. Or it can go into a third-party housing management system, or in this case, CGI's Smart City Management System for City of Edinburgh Council. But the sort of proof is in the pudding, really, and when we go and start talking to a customer, one of the first questions is always, how do you derive all of this from what is relatively simple data? And most of the time, that's just by keeping it simple. Don't try and overcomplicate it. IoT is complicated enough, or it can be. So start with a simple use case and build on that, and don't try and overcomplicate what you're doing with the data, sending it to too many places, trying to be too smart with it. So we basically talk through a bunch of different case studies, and this is the first of about, I think, 3 or 4 I've got here. And fuel poverty, as I've mentioned, is a real big issue. Always has been, and is just going to go off the charts this winter, to be honest. We've been seeing homes last winter that are sitting occupied, sitting between 4 and 7 degrees centigrade inside the home. If you try and sit in your home at 12 to 15 degrees centigrade, you'll understand pretty quickly how uncomfortable that is. So this is a home that we monitored, and our system highlighted it as a potential issue. Basically, whenever it got to this sort of November the 7th and onwards, we're seeing indoor temperatures here of 8.5 degrees. Big issue. But the decline into that from 20 degrees centigrade on the left-hand side here over to 8 degrees is something that we now can detect, or now know that we can look for over a 2 or 3 month period. But what's probably more interesting here are these spikes. And we never thought we'd be able to predict stuff. We'd really be having to identify stuff after the fact, but at least we were intervening before it got too bad. This is an indicator because these spikes are actually when this lady was getting paid. So she was only able to heat the home when she was getting paid. And as you can see, they get further and further apart until eventually she lost her job. So we are looking at this to try and detect stuff ahead of the game, intervene, and obviously improve it. And it's the outcomes, the positive outcomes, obviously, is what we're looking for, which is what we're seeing here. Another similar kind of situation. We've got 3 rooms, the temperature for each being shown here. Blue is the main bedroom, second bedroom is red, green is the lounge. And basically, again, this lady couldn't afford to heat her home, so she didn't heat the lounge at all. She only heated properly the main bedroom where her daughter was staying. She didn't heat, really, the second room that you can see, the second bedroom that she was staying in. Obviously, again, system acknowledged this, saw this, highlighted it to the landlord, and in this case, a fuel voucher was deployed, if you like, and you can see the difference it made instantaneously. So you can instantly see that it makes the home far more habitable. So I mentioned earlier how we got into this in the first place. We used to work in electricity distribution networks, monitoring them to make sure they were working all right. Just check the time, and make sure that there weren't any bottlenecks. And basically, our first customer came to us and said, we've spent £18 million in the last 4 years retrofitting some of our homes, making sure that they are more energy efficient. We have no idea if it's made any difference or not. Basically, they'd been given money to go and carry out this retrofit work, but they just didn't know if it had actually made a difference. They knew in theory that it would have made a difference. And so we were able to show that, yes, it's made a difference. It's lowered people's bills. The temperatures are higher. The consumption has gone down. But one of the problems is when you're putting on retrofit cladding, you're effectively putting a plastic bag over a building. And with that, you're trapping in moisture if the ventilation systems aren't up to scratch. So we were able to identify basically that this is what had happened. There was 10% higher humidity levels in some of the properties that had been there before. And that came down to the quality of the cladding. So retrofit is something we started off in. It went a little bit quiet for a couple of years, but now it's massively on the uptake again, as you would imagine. Everybody's being driven to do it. By 2025, anybody who rents out a home that's coming into a new tenancy has to have their home at EPC rating. By 2028, anybody who rents out a home in any format basically has to have their home at EPC rating. So what we're seeing now is that anybody who is funding this is basically demanding, I suppose, that that work has to be monitored to prove that it has had the impact that they hope for. And this is an example of why, because not all retrofit work goes to plan. Not all contractors will do as they were meant to. This is a home not far from here that our system identified pretty much immediately after retrofit work was carried out that there was something not right. Top line is humidity. Red line is CO2 levels. Top line is sitting at just over or just around about 80% humidity. That is really bad, especially for an empty property. Should be sitting around about 45, 50, something like that. The bottom line here, sort of flat-ish, basically shows there's nobody living in the property. The spike here is when people were going in to carry out some work, and then they disappear off again. But clearly there's a change around by October the 24th when the tenant moves in. And the system had been saying for 4 months, this is going to be an issue. 3 weeks after the tenant moves in, they have to be taken out again because the system, basically the retrofit work hadn't been carried out properly, the property hadn't been dried out properly, and the ventilation system failed. So the combination of all right temperatures, but really high humidity and high levels of CO2 basically instantly started growing mold in the property. Again, retrofit work, this is one of the things for the energy monitoring that we do now. You can overlay energy monitoring with the temperatures. You can see when the heating comes on. And in this case, you can see how quickly the temperature is dropping. You're seeing a drop here in some cases of nearly, 10 degrees centigrade in 8 hours, something like that. That home clearly isn't energy efficient. And again, I think this one turned out to be, it was in a top corner flat down in Manchester. And when the landlord went out to identify what was going wrong, they went up into the loft above the flat to find out that the insulation was up there, but it was still all rolled up. It hadn't actually been rolled out. And this is not unusual. It's a bit like the other story. They hadn't actually activated, it wasn't a failed ventilation system. They hadn't activated the ventilation system. So it's things like this that where you can really use IoT. One sort of final one, I think, is there's so many different ways with an IoT project. Go into it with your eyes open. There's so many different things. Anything is possible. If you have a problem, you can use IoT to solve it, probably. This one is benefits fraud, basically. These spikes, as I mentioned earlier, the flat lining basically means that there's nobody there. These spikes indicate that somebody has gone into the property, and they happen to be a month apart. So somebody's going in there only once a month, basically to collect their post and get whatever they get from it. Now, you might think, well, there's no harm in that, but if this home isn't being lived in, somebody is living elsewhere, and therefore somebody more needy needs to be living in this home. So they need to get this property back on the market, never mind the fraud part of it. So that's quite a big thing with either fraud or abandoned properties or whatever it is. But properties need to be getting used. We already have a shortage, so we need to make the most of what we've got. So yeah, as quickly, standard offerings, you can do all sorts of different use cases. The last one is the puppy farms. Lockdown, everybody bought dogs, it seems, and therefore puppy farming went through the roof, and therefore social housing was turned into puppy farms in quite a lot of cases. We haven't found any yet, thankfully, but that was one of the latest ones that somebody asked us to look at. More standard stuff, Legionella, fire doors, emergency lighting, all the kind of stuff that is pretty boring, high cost but low value kind of work you can do with IoT. And it's not unique to older buildings. New buildings all have similar kind of problems, and that's mainly because of us. People are awkward. People don't live by the standards and go very repetitive. People's patterns change, et cetera, et cetera. So don't think that just because you've got a brand new, nice building like this, that everything will be tickety-boo. It won't. And that's me. There you go. Thank you. I'll leave that back there.